All right, we're going to take some notes in class today, but I'm going to ask that you try and take these notes at first on your own. So if you can pause the video and try and complete page 1, all on your own, of the 04 projectile notes, which are on Schoology, we will see where we get. So go ahead and pause the video now, get those notes, answer all these questions, and then when you're ready, come on back and we will talk about the answer, okay? All right, so for number 1, hopefully you drew a little cliff, and you drew a projectile, and you drew its path, and it looked something like this when it hit the ground. That's all we really wanted you to do there, okay? And if you'll notice, we're going to talk about how this looks like half of a parabola. If we throw it in the air at an angle of 60 degrees, we're going to get something that looks a little different. We're going to have a full parabola that's going to come up, and that should be symmetrical, but I didn't draw it very well. Okay, so that should be a full parabola. For number 2, hopefully you remember from our study last year in dynamics that there's only one force acting on the object once we throw it on the air. Only one, because we're neglecting air resistance. And that force is the force due to gravity. And we know that the force due to gravity always points directly down. So if that's the case for number 3, that means our acceleration has to point directly down. It can't be at all in the horizontal direction, okay? So when we look at figure 4, and we're asked to draw the acceleration vector at the points marked on the path, you should have drawn a vector, and I'm not doing a very good job here. Should have drawn vectors that were going straight down, and they should all be the same size. So if you're doing that in Notability, you can just copy and paste the vector as you go. All right, I'm going to ask you to, when you get to page 2, I'm going to ask you to do the same thing as we did with page 1. Go ahead now and try and complete page 2 on your own. So pause the video here, complete page 2, and then when you come back, we will take a look and see what you should have drawn, and you can make any corrections you need to. All right, let's go ahead and let's start with the horizontal component of the velocity vector for number 5. And that should be perfectly horizontal, and it should be exactly the same length for every single location, because there is no acceleration in the horizontal location. So there can't be any change in velocity. So the component in the horizontal direction of velocity has to be exactly the same every single time. Now that's going to be different than the vertical direction. We know in the vertical direction we have acceleration going down, and our velocity is going up. That means that our velocity at first, for this first half of the parabola, has to be decreasing. So whereas here I'm going to have a large velocity, here I'm going to have a little bit of a smaller velocity, and by the time I get to the top, the velocity in the y direction or the vertical direction is 0. Then we know as we start coming back down, it gets bigger and it's symmetric, so it will be larger even there, okay? All right, let's take a look at the second one. Now we want to draw the full vector. And what we're going to see is that for the full vector, that's going to be tangent to the curve. So we've talked about tangents to circles before. So we're going to go ahead and show that the velocity vector is going to look something like this. And it's going to decrease as we get higher. It's going to be its smallest up at the top because it's all going to be in that horizontal direction. And then it's going to get larger on the way down, tangent to that curve right there. All right, similar to what we did with the first 2 pages, I'm going to go ahead and ask you to complete page 3 on your own up through just number 8 for right now. Okay, we're going to do 9 and 10 tomorrow, but let's see how well you can do with these other questions, including number 8, and then when you come back, we will talk about them. All right, hopefully these first couple are pretty easy. The vertical component of acceleration of a projectile is always the same. It's always the acceleration due to gravity, and it's always 9.8 meters per second squared. The horizontal component is going to be 0 because there's no net force acting on it in the horizontal direction. The vertical component velocity of a projectile at its highest point, right, the vertical component at its highest point, and we've talked about this before in kinematics, is always going to be 0, right? It won't have any vertical component when it's at its highest point. The direction of the velocity vector of a projectile at its highest point is therefore always going to be horizontal. Okay? So pretty straightforward there. Let's go ahead and take a look at this. An arrow is shot horizontally over a perfectly flat range. Just as the arrow leaves the bow, another arrow is dropped from the same height. Which arrow hits the ground first, if either? They hit at the same time. We have a demo in class. I'll try and post a video so you can take a look at that. But it's at the same time because they undergo the exact same acceleration, which is only the acceleration due to gravity. So the arrow that's launched is going to travel farther in the horizontal direction, but it's going to take the exact amount of time to hit the ground as the arrow that is simply dropped. Okay, that's our notes for today. I will post a video of the demo as well, and hopefully you'll be back in class soon. Take care.